So today we are going to see how we are going to generate the most stable chair conformation. If I give you cis and trans of one particular molecule of cyclohexane, how am I going to get the most stable chair conformation from that? So that's what is the topic today, most stable chair conformation of cyclohexane. So for this purpose, again we'll take some examples and we'll try to work it out. Okay. So before taking the example, there is only one rule which you have to remember, right? For me to have the most stable conformation, chair conformation, you need to put the most bulkiest group in the equatorial position. This is the only thumb rule which you have to remember. The most bulkiest group must be in the equatorial position. So if this you can remember, and if you can engage in the previous video, you will be able to easily get out the most stable chair conformation of cyclohexane, right? So now I think you understood. We'll directly go for the example. So we are going to take the example of 1 ethyl 2 methyl cyclohexane, right? So again we have to take, I have to put a specific case of whether it's going to be cis or trans. So let me take cis 1 ethyl 2 methyl cyclohexane. So we'll directly put the planar structure first and then we'll go for the chair forms. So planar structure will look like this. It's cis, so hope you understood, either both pointing away or both pointing towards you. Say I put the ethyl group pointing away, C2H5, and since it is cis, in the second carbon atom also I need to have the wedge with a CH3. So this is how cis 1 ethyl 2 methyl 1 ethyl 2 methyl cyclohexane looks in the planar form, right? So now we'll be able to easily incorporate it in the chair form. So that also we'll try to do, right? Okay, into the chair form if I have to make. So okay, so let me put the required bonds only. So here axial up and equatorial down, and in the second carbon atom axial down and equatorial up, right? So I didn't fill the other things because only these two are required for me. Okay, so fine. Now I already told you, in case of chair, it is not at all about whether it's going to be axial or equatorial. It is about whether it's pointing up or down, right? Now since it is cis, right, so I have to make sure that both of them are going to point up or both of them are going to point down. Okay, now I'll take the first carbon atom where I have the ethyl group. Now remember the thumb rule, I am directly going to get the most stable chair conformation for this particular molecule, right? And what is the thumb rule which I have to remember? The most bulkiest group must be going to the equatorial position, right? Okay, now I have the, out of these methyl and ethyl groups, obviously the more bulkier group is going to be ethyl group, isn't it? So I'm going to put it in the equatorial position such that it is going to become most stable. And obviously I look at here, pointing down here, it's going to be equatorial, and I'm going to put this C2H5 group here. Very simple, just putting the most bulkiest group in the equatorial position. Okay, what is remaining now? In the second carbon atom, I'm going to have a methyl group. Now you have to remember it is cis. So here I have put the methyl group to be pointing down. Definitely you have to put the methyl group also to be pointing down. And in that case, it is going to be axial, right? So obviously you understood, this is what is a cis, and I'm directly putting the most stable form where I put the most bulkiest group in the equatorial position, and accordingly other thing changes, right? So we'll take the same example with trans and we'll see what happens, right? So I am going to take trans 1 ethyl 2 methyl cyclohexane, right? Okay, so let me draw the planar structure first. So say I put the ethyl group to be pointing away, so definitely it is trans, the methyl group should be pointing towards you. Very simple, right? Cool. Now we'll try to incorporate it into the chair form, right? So we'll draw the chair first. Okay, the chair. Let me put the axial and equatorial bonds. Cool. Is it done? So now again the thumb rule for the most stable conformation, most bulkiest group should be in the equatorial position. So let me start with the first carbon atom. I will put C2H5 in the equatorial position, which is pointing down, doesn't matter. Now it is trans, so I have to make sure that the methyl group is pointing up, because in the first position I have put the ethyl group pointing down, and here it is going to be pointing up, which is going to come here, right? Now let me ask you a question. Out of cis 1 ethyl 2 methyl cyclohexane and its trans form, which is going to become more stable, right? So in the previous pictures you would have seen that I had C2H in the cis form. You would have seen that C2H5 is in equatorial position and my CH3 was in axial position. But if you look at trans, see what happened. I had C2H5 in equatorial position and CH3 also to be in equatorial position. There are two bulky groups and both the bulky groups are in equatorial position. So if you ask me which is more stable, whether it's cis or trans, in this case trans is the more stable one. But again, don't generalize. There can be cases where cis is also more stable, right? So I hope you understood how do you get the most stable conformation, chair conformation for different stereoisomers of cyclohexane. Thank you so much. If you still have doubts, please put them in the comment section. And if you like the video, please like, share and subscribe. Thank you so much.